All right, class, we are jamming here. Let's see. So first things first. Grades. Oh, yes.
Oh, fun story. The new Wanda and Vision episode blew my mind. Yeah.
I know it's so strange.
I know. I was thinking.
Because I really,
Yeah.
I hate when
Yeah. I was like, that was it. I love Darcy. Darcy is actually my favorite character. Oh, today's Wednesday.
All right, now we're good. Boom. All right, let's see. Grades. I finally did them last night eventually. I had to put in just your challenge problem scores. So after that, please take a look at them. If you see something's off, please email me. I thought they were due Monday originally. And then I'm like, what? Saturday night. I'm like, I have all this time in the world. So, but they are due tomorrow because we need to input them on Friday. So anyways, please do so and go from there. So if there's something off, please tell me. All right, next thing is presentations that I got to see. I'm thinking, oh man, that's not so cool because you guys should have been able to see them too, but oh well. But I had a fun time. So these are just the topics, not all of them, but maybe a good handful that I was kind of just recalling real quickly here. Thought that was kind of cool. Criminology, how we look about blood splatters and how we evaluate crime scene. I think you guys know who did that one. Okay.
Someone who knows a lot about blood in this class.
It tries to develop a crime scene, so never mind. We had aviation and why we fly a certain way, because it's called the Great Circle. History of navigation on water, and all the trigonometry there. Disneyland and the sites, how buildings are made so that they look interesting. History of the sine wave, sine. Oh, this is an interesting history of the sine and cosine and tangent tables. So yeah, there's this whole concept. Yeah, you got the function, right? But then how do you start figuring out table form? So these are the values, right? So that how that came about. History of the tangent curve, and the reason why we call it tangent is anybody? That's a French word, is that right? Latin for touch, because technically the tangent line, as we think about it in calculus, it's the tangent line touches the curve at a certain point. So that's where it's at. All right, Escher. Anybody seen drawings of Escher? Escher's drawings. Okay, had a whole history about him and what interested him doing that and all the good stuff here. That was cool. Moon cycles and also music and trigonometry, and then ballistics, blowing stuff up. And then the history of the law of cosines, which is something we'll get to in chapter 7, I believe, eventually. Anyways, we're good. I had a blast here. Did you guys enjoy it? Just, sort of. Okay.
We only had our own experience.
The timing was interesting, but other than that, it was a cool project.
Yeah. Hindsight, I would have made it do in class so everybody else hears it as well, because that's the whole point. And if I did not think grades were due Monday, we would have maybe done it today or something like that. So that was my bet on that. Okay, next is presentations, and we are starting 5.1, and I got to give you guys a homework sheet sometime today when I email it to you. Yeah, Grace.
There are grades to check our grades to make sure you got everything right. Are you just saying we check on Google Classroom to see how you graded everything, or is there the place where we can like see our final grade on there yet? Or how does that work?
You should be able to see your final. So whatever percentage shows in Google Classroom, that's your percent of the class.
Right.
And so then it's just a normal grading system. Okay, cool. Thank you for that question. All right, let's jam. Boom. We are at I think I'll do it that way. Right. Oh yeah. And let's see, so chapter 5. Chapter 5 is, I forgot the identities and formulas. Oof. Identities and formulas. This is really getting us to chapter 6 when we're going to start solving equations. If you guys think of your algebra days, right, or if you don't want to, but just think of the content of algebra days. If you think about the overall structure of algebra, you should think of this in this category. It should be linear functions and all the stuff you do linear functions. So you add, subtract, multiply, divide them, right? Then you graph them. And then you graph simultaneously, which means more than one in the graph. Do you guys remember something like that, right? Then you move on to polynomials or quadratic equations or functions, right? Then again, add, subtract, multiply, divide. Then you learn how to graph them. And then you learn how to compose them. You guys remember that? Like f inside g of x. It's a function inside another function. Remember those? No, okay. Some do.
Yeah.
Okay.
I remember it, I don't know if I remember the process.
Gotcha, okay.
Yeah.
And then we have, and then the whole, for polynomials, the whole new thing is factoring, right? The factoring is when you do polynomials. And then you should move on to rational functions. So fractions, right? That you got to simplify, add, subtract, multiply, divide, and graph. Radical functions, is that good? Radical functions are the next one. Add, subtract, multiply, divide. Simplify, and usually, I forgot what I was trying to do, solve. Usually the last thing to do is you solve all these things. So you should be able to solve linear functions. You should be able to solve quadratic functions with factoring, right? You should be able to solve rational functions, you should be able to solve radical functions, and now you should be able to solve trig functions. That's the whole point here. Okay, so we're moving on to the last part here. Okay, so I need your help. You guys need to tell me all our identities so far. So I think I have them like this: reciprocal, if I can spell correctly here. Reciprocal identities, name me those, and then ratio, and then we'll get to the Pythagorean theorem identities. I know it feels like a Monday, doesn't it? But can you guys remember anything about reciprocal identities?
That's not the one that it's like 1 over.
It's the 1 over.
Okay, so like 1 over cosine equals secant. Or no,
Okay.
wait, yes.
Yeah.
We're gonna have to do this. How about this? This row has to come up with 1. So Corinna and Hayden, you guys have to come up with one reciprocal identity. May I think saved row 2. What did you say, Maya?
I said 1 over cosine equals secant.
I'll go with that. Okay, row 3.
Wait, so are we saying ours?
Yeah, in just a second.
Oh,
I'll let you
okay.
guys. 1 over sine equals cosecant. Awesome. No, just kidding. Row 1.
Wait, so is it sine over cosine equals tan? No.
No, be
No,
ratio.
cosine over sine equals cotangent.
Okay, we can do those. We can do those.
Oh,
So,
that's for ratio.
and let me do it the other way here. So how about tangent? Tangent theta is sine theta over cosine theta. That'll be good. Okay.
Cosine equals 1 over secant.
Okay. 1 over 1 over secant is equal to cosine. Okay. Da da da. Adrian, I think I heard you.
You want a reciprocal one or ratio?
Either one.
Tangent is equal to 1 over cotangent.
Oh yeah, there it is.
Great job, Adrian.
So 1 over
I'm so
tangent is equal to cotangent. See, TA. All right, I'll fill in the rest. Sine, then the other one would be right here. This would be 1 over sine. And then 1 over cotangent theta would be tangent theta. Okay, are we good there? I think that's all the ones we know. And the other ratio identity? Okay, fine. I'll do it. I'll do the last one. Cotangent is cosine over sine as the ratio. Okay, so chapter 5, we're going to learn all about identities, all the relationships between all the trig functions here. And we're going to have to prove identities. And we're going to come up with very interesting identities. So by the time you end, you're going to have a lot of formulas on your hands.
I always wanted to work.
I know. That was
You know,
so cool.
I've been just thinking for my whole life, ever since the day I was born, darn, I need more formula.
There you go.
I agree with you.
Yeah.
I agree.
Depressed because of lack of formulas.
Yeah.
Exactly. That's the reason I'm
Okay, talk to me if you guys are all done. I think I kept them in somewhat order.
Yeah,
Not in that way, Graham.
We're all back at school for like 5 minutes.
I've been done since yesterday.
You're on break.
I know.
All right, the Pythagorean identities. There are 3 of them.
Shokatella.
That is definition of a triangle, how we coordinate the different sides. So sine is opposite of our hypotenuse, and all that good stuff. Adrian?
It's the obviously very useful ones like cosine squared or sine squared.
Oh, yeah.
Yeah, there you go. That's the one.
Maximum use out of those.
So we're gonna list a lot of let's list it this way here. So cosine sine squared theta plus cosine squared theta is equal to 1. All right, and I think you guys can easily draw the fact that it could be cosine squared plus sine squared equals 1, right? That's
Yeah.
easy enough.
Whoa.
Except for Grant. So then let's do the other ones here. So you will probably use something like this. If you subtract sine squared theta from both sides, you get this one. If you subtract cosine squared theta from, actually, no, hold on one second. This would be easier to do it this way here. Then how about this? Cosine theta is equal to plus or minus the square root of all that. Are we good there? Agreed? And then we go the other way here. So then if we go back to the original one and we subtract cosine squared from both sides, we get sine squared theta minus 1 minus cosine squared theta. And get to fill in the rest of it here. So we take a square root of both sides, plus or minus, don't forget that, because we're just doing abstract terms here. Now, when you deal with a triangle, you're going to deal with it a little differently. Or if you have a domain restriction, you're going to be dealing with it differently. The plus and minus will go away. Okay, we good? Or you're going to choose which one you want. Okay, anybody think of another Pythagorean identity?
I mean, I have the textbook, so it's just cheating.
Adrian,
Cheating.
why would you tell us that? And just keep saying
I
this
mean,
after
if I
you.
say all of them, I'm pretty good.
Yeah, does everything.
It's not cheating if the teacher knows.
Just puts you on copying all of my
Pretty
answers
sure
on
it's
the test,
pretty
so
good.
it's not cheating, but it's telling you.
Okay, Adrian would have said 1 plus tangent squared theta is equal to secant squared theta. Okay, now can you guys give me all the different variations of this guy? That's what we want. So let's see, the first one would be subtracting. This is interesting, subtracting 1 from both sides. Are we good there? Actually, that tangent squared theta is the same thing as. That's interesting. So if we ever get stuck, we might just use that one.
Or -1 plus secant squared theta.
Yeah, -1 plus secant squared theta, I prefer that.
I'm gonna let that go. So then we have this. Okay, what's another thing that we can do? Oh, we can do the obviously. Go back to the original one here, and how about let's just take the square root. So secant theta is equal to plus or minus the square root of. Okay, already good there. And one more. I think one more is this one right here. How about if we, from the original one here, we subtract tangent squared. So actually 1 is just equal to secant squared theta minus tangent squared theta. Huh, never thought that would be like a 1, but it is. So whenever we possibly need to substitute, or for granted, it'd be negative tangent squared theta plus secant squared theta. Okay, and then what usually happens is we learn a whole bunch more knowledge than we need later on. So are we going to use every single one of these for chapter 6? No. But are we going to have a good majority? Yes. And do we need to know the concept of it? Yeah. So, okay. And Adrian's up with the third one.
Boy. 1 plus cotangent squared theta equals cosecant squared theta.
Awesome. Okay. Based upon the previous one, all yours, can you, because it's very similar, can you give the other variations? So think about what we did on the previous one. So the first one that we did is we just move the 1 over. So you have too early in the morning for me to think.
Oh, do you want us to say it? That would be cotangent squared theta equals cosecant squared theta minus 1.
Tangent squared theta is equal to cosecant squared theta minus 1. Perfect. Then I think what we did is we, just to get the next one, we took the square root. So plus or minus the square root of cosecant squared theta minus 1. There's that one. Let's see, let's go back. Then that one was, oh, the obvious one of taking the square root from the original one, plus or minus the square root of 1 plus cotangent squared theta. Boom, and any others?
1
I think you got it.
1 equals cotangent squared theta minus cosecant squared theta.
I think it's cosecant squared
yeah.
theta, right? Because we moved the cotangent over. And we are good. You get to hide. Thank you. Cool. I think we're good. That's all the identities we know so far, right? The reciprocal identity, ratio identities, there's only 2. And then these Pythagorean theorems that have many variations here. Okay, so let's go back to what we have been doing previously and make it more difficult. So do you guys remember proving identities?
Yeah.
So we're gonna just deal with, you know what, today I'm just gonna give you just exercise 1 only, and that's it.
Exercise P.
Proof, it should be a 1 in there. Prove that each of the following identities are true. Now, you guys have it easy. When I was in school, the textbook that we had, actually, you did not know if it was an identity or not. So what you would do is you would circle out for about 2 hours until you find, like, that's not an identity. So then if it is, and if it is not an identity, then give a counterexample. But if it is an identity, then prove it. That was no fun. Okay, so let's go with the A. And we'll switch over to this now. Okay. Easy ones. Let's start an easy one. In fact, we've been doing these a while, haven't we? I think we've seen something similar to this one on the final. All right, so for these guys, remember the left side remains the left side, right? So we're not solving an equation here. We're not trying to get theta by itself. We'll do that next time. Here, we're just trying to prove the identity. So prove that one side is the same as the other, and we're going to simplify them until they're the same. And we usually go down. So easiest thing to do, 99% of the time, we're going to convert things into sines and cosines, because that's the easiest way. Those are the base values we know, and we know a lot of identities with them here. So cotangent again is?
Cosine over sine.
Yay, and if we can keep on scrolling down if we like, but this turns into a 1, sines cancel, and we have the Latin phrase, which is abbreviated as that, or we got a box.
So if you did like cotangent equals cosine over sine, that wouldn't be proving it, it'd just be showing us that that's what,
Over here.
yeah.
So if we had something that looks like this, cotangent is, whoa, cosine over sine like this.
Yeah.
Started that, we would go back and say, okay, it doesn't matter which one we go like that. So I said 99% of the time we are going to do that, or you could just convert it into cosine theta on one side and cotangent theta on the other.
Okay.
What you really are doing here is you're using the identity from here to here, right? There's your identity change. Like, oh, ratio identity, gotcha, boom. And then here's some algebra to go along with it. Okay. So we can cancel top and bottom of a fraction. So identities and algebra, here we go. Let's see, no, pre-algebra, right? It's just simplifying. Easy stuff, we good? All right, we'll make it harder. Can you prove to me tangent x plus cosine x is equal to sine x? All right, make it a little more interesting. So there's some algebra stuff. And this is where you can say, you know what? I was doing math today and there was not a single number inside my math equation.
Oh God, that's true.
All right, talk to me. What do you guys say? I'm thinking because we have plus signs everywhere. So for the left side, I'm going to convert in sines and cosines. For the right side, I think I'm going to multiply the sign into those. I'm going to distribute that sine of x. At least that gives me a little closer, and let's see what happens. All right, I will tell you this here, past experience teaching this here. Sometimes what you do is you go sort of round and round, like, how do I do this, right? So you just have to go back to your previous identities and think, okay, how am I going to process this? So sometimes it's just an algebra issue. Sometimes you just don't know which identity to use to get to where you want to get to. Again. All right, it's all yours. This is what I'm going to do. Sine x over cosine x plus cosine. Okay, I got that side. This one, I think I'm going to just distribute here and see where I'm at after I distribute. I could be exactly where I want to be, or I could be somewhere different. So let's see. All right, thinking about this here. What a fun game. Let's see. Because my whole goal is not to simplify each side completely. My whole goal is just to get the sides to look the same. So I'm thinking, you know what? Since I have everything in terms of sines and cosines on the left, I think I want to now turn my attention to getting everything in terms of sines and cosines on the right as well. So secant is 1 over cosine multiplying by sine of x. This guy, cotangent, is, oh, this is so cool. Okay, hold on, it's getting there. Cosine over sine multiplying by sine. I think I got where I wanted to go to. The first term right here is now going to be sine of x over cosine of x. Everybody read there? And then the signs cancel on the other term, and I have exactly what I want right there. I am done. I prove both sides to be the same. No one has asked me. I mean, like, I left it out there as a question. So 99% of the time, we change everything to sines and cosines. The 1% that we don't is if you just automatically see like this relationship happening. Like, oh, if I can just use this identity, I'll be done. That's kind of the only time that you don't convert into sines and cosines. Does it happen? Yeah, 1% of the time.
So even if it's not the first step, you all, or 99% of the time you want to have it in sines and cosines.
Just easier that way. Doesn't mean you have to do it that way. You can go around and around trying to figure out with tangent.
No.
I suggest you don't. Okay, all yours here. Secant squared x multiplying cotangent squared x plus 1 equals 1. Ooh, how fun. I don't think we can simplify 1 any more than we are. Again, one of those here, would you distribute or would you change it to sines and cosines? I think I would distribute here first, right? Just to get all of them where they need to be. So I would distribute here. And my only condition that I have here is cotangent squared x plus 1. Going back over here. I know I have a cotangent identity. Oh no, hold on. Cotangent identity is linked up to cosecant, not to secant. Okay, so didn't use that one. That's no fun. Okay, cotangent squared x minus secant squared x, and you could have done yours differently, and that's totally fine. Cotangent squared now is going to be cosine squared x, is that right? Over sine squared x multiplying. This is going to be 1 over cosine squared x, okay? And this is 1 over cosine squared x. All right, do you need to keep on writing the 1 all the way down each time? You don't, just as long as you know where you left off on the other side. So I got a little thing that happened here. How about this? One thing that happened is Mr. Njeev didn't write down the problem correctly here, so we're not going to get to our answer. So how about we do this here? We're going to start this one all over. This guy has to be sine squared x. Sine squared x multiplied by tangent squared x.
Wait, the secant one?
The secant squared, yeah. So Grant stepped out right on time.
Thank you.
Okay. Should we put again? C again. All right, this one, let's see. You can distribute the sine of x squared if you like. And another thing is, if you check with your neighbor next to you, they may, especially when you check homework, they may have done it a different way than you. We're good? So there's multiple paths to the end over here. So let's do it kind of 2 different ways here. So multiplying the sine squared x in gives us sine squared x cotangent squared x plus sine squared x is equal to 1. I will leave that out. Let's see, sine squared x multiplied by, what's that going to be? Cosine over sine. And it sort of slowly comes together. Cancel, cancel. And some of you guys are done. Absolutely. You do want to have this little end at the end. You just want to bring down that 1 to say, look, that side is now the same as that side. I am finished. And that which was to be demonstrated has been demonstrated. Oh, cool. Okay, let me show you a different way. So I like C for some reason. So how about this? C again. We'll call it a third time with one mistake. I didn't make a mistake this time. Just want to show you a different way here. Boom. Go back and look at Pythagorean theorem identity for this guy. What does that look like? Cosecant? Cool. And then it's going to be cosecant x in this instead of theta. Oh, I like this one better. It's a little faster, isn't it? Because that changes to a reciprocal identity called that, which then just becomes this, and I'm done. Love it. Notice we had to use the Pythagorean theorem identity sometime, right? That sine squared x plus cosine squared x. So you could have used a different identity to get you going there faster. Super cool stuff. Okay, D. Yeah. All right. So let me do this here on the right-hand side, just for me to get things simplified real quick here. I think eventually I'm going to look for something like that. Is that right? Okay. On the left, now we got some work to do. I got 2 fractions on my hands. Therefore, I know I'm going to have to get common denominators. Start working it out that way. So I have a sine A multiplied by 1 plus cosine. Here's my 2 common denominators, right? The sine A coming from one fraction or one denominator, and 1 plus cosine A coming from the other. So one denominator and the other, and I'm making common denominators. So it looks like on top, I will be multiplying by, talk to me here. So this guy would have to be multiplied by sine A. Therefore, the top gets multiplied by sine of A, which gets me sine squared A. Are we good there? On this one, this one would have to be a multiplier of 1 plus cosine A. Oh man, this is no fun. We're gonna have to FOIL this out. So if you need to, off to the side of your sheet of paper, We're foiling out 1 plus cosine A, 1 plus cosine of A. So let's see how this works out. 1 times 1 is 1. Hey, this is just algebra with trig functions here. And let's see, cosine of A times cosine A gets me cosine squared A. So I got myself, tell me if you guys agree or disagree, 1 plus 2 cosine A plus cosine squared A. All right, man, lots of work on this one here. So I'm putting this now as one single fraction. I guess I can put the top as a single fraction as well. See if you guys agree there. So sine squared A plus 1 plus 2 cosine A plus cosine squared A. All right, anybody see something that we can put together?
Is it the sine squared A plus cosine squared A equals 1?
I'd go with that. This little piece right here, that little piece right there. That will just become 1. In this case, you can skip a lot of steps. You just want to make sure you don't make a mistake. So I'm thinking that's going to be a 1, but I also see a 1 in there already. So can I write it like this? I'm going to have to switch slides here. Here, 2 plus 2 cosine A. Okay, talk to me. Is that still okay there?
Wait, where'd you get the first two from?
Uh-huh. So this right here, that became a 1.
Oh, I see.
And then it's the other one right over here. So adding the 1 with the 1. Makes it 2.
You can simplify it to 2 over sine A because 1 plus cosine A. Wait. I thought you could take it out. I'm pretty sure you can.
Absolutely. On top, we have 2 terms with 2's inside them. That means we can factor. Yes, we are factoring stuff now. There's my 1 plus cosine A right there. Oh man, there's some, look at that one. That goes away. Of course, I got to show you a tough one, right? So 2 over sine of A is equal to 2 over sine of A coming back from the other side. Done. I am done. All right, all the trig books in the world, they either have QED, they have this little box. I don't know why the box is for, or they have a little check mark. So you can use one of those 3 universally accepted I'm done statements in trig books. Just a square.
Not even like a checkout box,
It's just a box.
It's just an empty box too. Okay. We're on D and E. All right, let's do, okay. So we were factoring. Let's do a little bit more complicated factoring. How about this? To the 4th power. All right. Changing the variable to t, just to confuse you and to confuse tangent. Bless you, bless you. All right, since we did start factoring here, let's see. Can we factor this guy down? Or you guys talk to me here. Think about it.
Can you change, or would it help to change 1 plus tangent squared t to secant squared?
You can if you like, absolutely. That's not normally the way you would want to go because you want to simplify as much as possible here, but you can do that. That's fine because eventually both sides the same. That's all you care about. All right, I'm more interested in that cosine to the fourth power.
Yeah.
Can we remove that?
The cosine on the bottom, is it? If you're dividing the exponents, it subtracts, right?
Oh, gotcha. Okay, from algebra, you guys talk to me here. Were you able to do this here? In algebra, can you just say, oh, I'm going to just take this and this down, this and this?
No,
Oh, no, because it's subtracting.
I wish.
Yeah, this is holding.
So much nicer.
It'd be so much nicer. Math would not make sense, but it'd be so much nicer.
Math doesn't make sense
Can we change
We
math
could
right
just-
now?
We could just decide that it's okay.
So algebra, x to the fourth minus y to the fourth. How would you simplify that? Even simpler. Well, how would you factor that?
Can you just pull off the four?
Can't pull out the 4 now because it's a exponent. Now x squared minus y squared. It's a difference of 2 squares, right? So it's y x plus 1, x plus y, x minus y. We good? There you go. It's x squared plus y squared, x squared minus y squared. So let's apply this over here. So this would be, let's see, cosine squared t plus, is that right? Sine squared t. That's the first one. That's this one right here. Then we do cosine squared t minus sine squared t over cosine squared t. Okay, talk to me.
Can you change the sine squared t and the plus cosine squared t to 1?
Oh, cool. Yep, that becomes a 1 right here. You don't need to cancel it, right? It's not a cancellation. It's not an algebra thing. It's a trigonometry thing. So that becomes a 1. So now we're left with cosine squared t minus sine squared t over cosine squared t. Still trying to get to somehow to get a secant squared in there. Love singing Jeopardy. Da, 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 da.
Why have one fraction?
Yeah. Yeah, Adrian, were you saying you'd like split it? So it's, yeah, cosine squared t over cosine squared t minus sine squared t over cosine squared t.
Oh yeah, hold on. We can we can
That's
go.
true, you can do it that way. Wow, that's crazy.
Wow.
Wow.
Although it still ends up being like minus tangent, so.
Well, let's do this here. Mr. Ngiev is learning how to write correctly here. So can we go back? Can we go back over here? And we come back to put this as a minus sign. Way better.
Okay, I was like, this is not gonna work.
Adrian's like, I don't know how we're gonna spontaneously generate a positive.
because the negatives overlay the plus, it's plus minus. We're adding a negative number.
So class, please go back on the right-hand side. It should have been 1 minus tangent square theta. So that means the secant.
Adrian!
So we split this off now. Is that cosine squared t over cosine squared t? Ah. Split the cosine squared t. And I think we're done with the minus sign. Look at that. I don't know. I'm for plus signs today. Okay.
Yeah.
Okay, sine squared over cosine squared becomes tangent squared t, and I have that. And dun 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 dun. I'm done. Minus sign. Better. Okay. Cool. We didn't get to one more example, but we'll wait till Friday to do that here. Otherwise, enjoy the rest of your Wednesday. You guys in a little bit, like 2 days.
Yeah.
Oh, there's a notebook.